Woohoo! Welcome back. Today we're going to be talking about integration of rational functions by partial fractions, which is just a fancy way of saying we're going to start integrating a bunch of fractions. A rational function or a rational expression is a fraction, but usually it's slightly more complicated or complex than are just fractions like 1/2 or 3/4. These are going to be fractions that have x's, other variables running around everywhere. And so to help us out, I've invited one of our favorite carnivores, Sparkly Vampire, to join us because he knows all about things that hide underneath. And this section deals with integrals of rational expressions. The first type we'll look at are those of the form. And now I've got to tell you, the book uses these letters, but I've seen really different letters used in other books, so I'm not sure why they chose these ones exactly. But R of x is P of x divided by Q of x. And I've written it out vertically as well, so that if that helps at all, R of x equals P of x over Q of x. And specifically in this section, we're ultimately going to be working with situations where the degree of the numerator is greater than or equal to the degree of the denominator. So in other words, this is what is commonly called an improper fraction. And we're going to be dealing with these eventually, but first we need to review natural log. So 7.4, we're getting a break from all the trigonopalooza, and we're going back to the basics with natural log. So, shall we get started? Woohoo! I know, I'm excited. I hope you're excited. Sparkly Vampire is sparkly, if nothing else. So, first question. What is the derivative of natural log of x? And the answer is, and hopefully you also know this, but if not, you want to make sure this one should be memorized. This one should be one that you know right off the top of your head. The derivative with respect to x of natural log of x is going to be 1 over x. Right? So it's the derivative of x over itself. So this sets up a really cool pattern that we can use to evaluate a bunch of integrals. If we see a fractional form where the numerator is 1 degree less than the denominator, then we can set up a derivative over itself. So that's what we're going for. Now, at this moment, you're saying, wait a minute, you said this. And I said, yes, we're going to get there. But first, let's review the natural logs. Okay, come on, Sparkly Vampire. Here we go. Woohoo. So now I'm going to throw all caution to the wind. Let's go ahead and do some integrals. The integral of dx over x. Now, if you were watching me, you're like, wait a minute, if the derivative is 1 over x, then the integral of what is effectively 1 over x dx should be natural log of x, right? And then plus c, of course. And the answer is yes, it is, except it is this. It's natural log of the absolute value of x, because natural log of a negative number isn't defined. Natural log only exists when x is greater than or equal to 0. So the domain of natural log of x is x has to be strictly greater than 0. Okay. So we got to remember that absolute value. That is going to complicate things a little bit, but just remember it. And it generally, it doesn't make things harder. It's just one more thing to remember, hopefully. Fingers crossed. Okay, you with me? Okay, here we go. Let's do this last one. Now, how does this differ from this? Well, dx over x is generally seen just doesn't have any surprises in it. It is literally just talking about x. Oh, hello, Chai. Chai is here to help us out. Hello, Chai. Okay. Yeah, come over here. Oh, there you go. Okay, I do this right in front of her favorite window, so she's bird watching right now. Also a little math watching, just, keep tabs on me. Okay, so what do we get when we've got the integral of du over u? Du over u generally, I guess we're all done with that. Okay, there you go. Du and u are frequently the variables we see when we're seeing a substitution. So a lot of times if you see u in an integral, it could just be u. Sometimes it's a u. Sometimes a u is just a u. But a lot of times a u is actually hiding a substitution. So I wanted to go over this as well. The integral of du over u, right? Again, it's 1 over u du is natural log of the absolute value of u plus c. What do you think, Sparkly Vampire? Yeah, he's all about basements. Loves the basements. Woohoo! Okay, so far so good. So now how are we going to use this? How are we going to use this? Did you see what I did there? I know, I'm brilliant. Dun dun dun, dun dun dun. Sparkly Vampire loves the dun dun duns. Okay, so what I want to do is find the integral of 3t minus 2 all over t plus 1 dt. And at this point, if you're not looking down here, don't look down there. If you don't look down there, you're going to say this is not du over u. This is messy thing over messy thing. They have exactly the same degree. First degree on top, first degree on the bottom. And so what we're going to do is we're going to divide. I know, it's like everything you love. It's integration, it's fractions, and it's long division. I mean, what else could we bring in, right? Alligators. Actually, alligators would be pretty cool. Yeah, we're all in agreement. Okay, so I'm going to take this expression, the 3t minus 2 all over t plus 1, and I'm going to treat it like a division problem. And I want to make a note. I'm going to move Sparkly Vampire over here. Thank you so much. And I'm going to remind you in this note that if I have something like, let's say 3 over 6, pardon me, that actually is another way to write 3 divided by 6. And how do you remember this? Well, look at the division sign. The division sign has a line in the middle and then a dot on top and a dot on the bottom, almost as if it's looking back to this fraction. So I'm going to use that same understanding of a fraction's relationship to division to do it this way. Now, when you're dividing, I don't know if you have this trouble, but when I have a division problem, sometimes I get confused about who is the divider or the divisor and who is the one that gets divided, which is known as the dividend, oddly enough. I know, the things you pick up when you're teaching math. Pardon me again. So we're going to do old school long division. So I write my division sign there. And then the one that gets divided is going to go inside the box. So that's going to be 3t minus 2. And the one that's doing the dividing, divided by, that goes outside the box. And this is something that I frequently have to review because I have trouble remembering it. It's a straight up remembering problem for me. And so I encourage you, if this is something that's hard to remember, who goes inside, who goes outside, and you know any mnemonics, please share them with me because I don't have any really good ways to remember this. Except that the monster in the basement is the one that comes to get you. I guess that's what Sparkly Vampire would like to point out. The one that's in the basement is the one that comes to get you. So the denominator is right there. So here, that denominator right there is the one that's outside the box. Okay, so hopefully you remember how to divide things that aren't strictly numbers. You can divide expressions exactly the same way you divide numbers. And again, this may be something you need to review, or something you need to learn for the first time if you've never done it before. Basically, what you're going to do is you're going to look, just like with numbers, you look at the very beginning of the expression, the leading term, the term that has the highest degree, and then you look at the very first term in the expression inside the box, inside the dividend. Again, the highest degree term, the leading term. And I'm going to say, what times t gives me 3t? I'm not going to worry about the 1. I'm not going to worry about the 2. I'm just looking at the t and the 3t. And I say, oh, 3. 3 times t gives me 3t. So then I'm going to multiply 3 times t, 3 times 1. Okay, so first, so we got 3, right? So that's the first step. Here's our first step right there. Then you're going to multiply and you're going to multiply it times the whole t plus 1. So far, so good? Now, if you know long division, you know that you pick the number, you multiply, and then you subtract. Subtracting across whole expressions, and some of these get very long. These could be 5, 6, 12, 100 terms long. You do not want to try to subtract in your head. So what I'm going to recommend is that your third step be change the signs. And then add. Oh, and you can't see that. Let me get that. Let me see if I can make this a little bit. There we go. So you can see the whole thing. So I'm going to have you multiply. There's step 2 right there. Then I'm going to change the signs and add. Remember that subtraction is just adding the opposite. So I'm going to go through. Let's see, I don't have anything pink. I'm going to use blue here because I've used all my other colors. So here, changing the signs right there, I'm going to change this to minus 3t and minus 3. And then I'm going to add. Okay, make sure you add these. So 3t plus negative 3t is 0. Negative 2 plus negative 3 is negative 5. So far, so good? Okay, so here is step 4. This is kind of also step 3 and 4 are there. Okay, now, can I multiply t times anything to get negative 5? And no, you can't make variables go away. So if you get to the point where there are no more t's in here, that's your remainder. Okay, so I divided 3t minus 2 by t plus 1, and I got 3 with a remainder of negative 5. Okay, so what does that mean? Draw a line here so you don't read across. So 3t minus 2 divided by t plus 1 equals 3 remainder negative 5. Okay, so then I'm going to say, hopefully in your past, again, you have done this long division and you know that a remainder just means you haven't finished. It just means what's left over and you haven't done the next division. So what we do is then we just say, okay, we'll write this as if we just haven't done that part of the division yet. Does that make sense? So we've got the negative 5, which I need to divide, but I just haven't, so I'm going to leave it for the next person. And we can write it that way, or we can write it like this. Whichever way makes it make more sense to you. Both are valid. Okay, kind of, sort of. Now, this alone, this technique of dividing expressions, may be new enough or rusty enough that you want to stop here for a minute and maybe go and review those topics. And you can talk to me, you can talk to the tutors. We're happy to help you out. Okay, you guys ready? Very excited about basements still. Sparkly Vampire, always up for a party, a fraction party. And so now let's go to the next page. Woohoo! So, remember that expression we have written down? The expression that when we divide these two, we get 3 minus 5 over t plus 1. All I do is I replace this expression with this expression in the integral, at which point it is fair to say, wait a minute, is that really helping us? We did a whole page worth of work. Is that really going to help us get anywhere? And Sparkly Vampire is so excited. Yes, it is. Because now the denominator is bigger than whoever's on top, which anyone who lives in the basement is very excited. They like a fixed fight. They don't really want a fair fight. No, they want to know they're going to win. Here, it's kind of evenly matched. Here, the denominator is bigger. Degree is 1. The degree up top is 0. That's great. That's Sparkly Vampire is very excited. And so we're going to split this integral into 2 pieces. And then take a look at what I did here. See if you agree. So 3 dt becomes 3t. Now, where's this 5 from? The 5 gets pulled out, right? Minus 5. And then notice, now I have 1 over t plus 1 dt. And if you like, and I didn't leave myself much room, so let me move. I know he's very excited for Sparkly Vampire. This is negative 5 times, oh, and I didn't leave myself a lot of room. What if we set u equal to t plus 1, then du is dt. So then we've got du over u. Does that help a little bit? Because you can see that this is going to be negative 5 natural log of u plus c. And then we've got it. Now, when does this work? When can I use natural log? Natural log so whenever we have an integral where down here the degree equals n, and up top the degree equals n minus 1. So we have to have one smaller degree, and then we can do this. Okay? So I recommend you take a break, go outside, find some grass, find some sunshine, find some rain, whatever's outside, go find it. Find some rocks. Rocks are great. And yeah, I know, Sparkly Vampire is here for a party. If it's a rock party, awesome. I like rock parties. And then come back. I mean, obviously hydrate and have some snacks and stuff, all that stuff. But then come back and try some homework that's just like this. Try the homework where it's the degree is 1 less than the degree underneath. The next step that we're going to do is going to be significantly more complicated. So these are all in the same section, but they are not the same problems. So really focus on this, set this, make sure you understand it, ask for lots of help, and then come on back. Woohoo! And I will see you in the next video. Know that I'm really proud of you, Sparkly Vampire, so proud of you. He would love to talk to you personally about this, I'm sure, and have a big rock party. But you guys are awesome and amazing and so very smart. And I really appreciate that. Thank you for all your hard work. And I will see you in the very next video. Woohoo! Yay! Oh, and math on and woohoo!